The word laser is an acronym for light amplification by stimulated emission of radiation. The concept of stimulated emission was proposed in 1917 by Albert Einstein. In the 1950s, practical research was performed on applying the theory of stimulated emissions to the creation of lasers, but it wasn't until 1960 that the first true laser was created by Theodore Maiman using a synthetic ruby. Many ideas for laser applications quickly followed. Today, lasers are used for surgery, hair reduction, skin rejuvenation, collagen stimulation, body contouring, and more. Lasers harness the power of light and control it. They have several special qualities. Lasers are monochromatic. This means that they emit only one color. They are coherent, emitting light as a thin beam that travels in a straight line. Lasers are polarized, which means their light can be focused onto a defined location or spot and can vary their intensity. These characteristics are different from the light that is emitted by a light bulb or the light emitted by the sun. These light sources emit many colors mixed together. They do not emit light in a narrow beam, cannot be focused to a small spot, and cannot be as intense as a laser without expending tremendous amounts of energy. Amplification. Amplification means that a very bright, intense beam of light can be created. The laser may be activated by a few photons, but then many more are generated. The initial light is amplified to make a very bright, compact beam. Stimulated. Stimulated refers to photons stimulating atoms to release more photons. An atom can exist in an excited state similar to a bow when it is stretched. When a bow is released, it releases its arrow. Similarly, upon relaxation, an atom emits a photon. When molecules in a laser are stimulated at high energy levels, they release photons. These photons, in turn, excite other molecules and stimulate the emission of more photons. Emissions. Emission refers to the giving off of photons. In 1917, Einstein described this process as stimulated emission. In a laser, photons bounce between two mirrors until enough excited photons have been emitted that some pass through the semi-silvered mirror at one end. These are the photons seen as the beam of a laser. Radiation. Radiation is a general term for anything that is radiated or given off by an object. For lasers, radiation refers to the photons which are being emitted. Differences between lasers and other light sources. Light bulbs emit a diffused, multidirectional light made up of multiple wavelengths. LEDs, like those found on your car radio or alarm clock, emit non-coherent light. This light is composed of a narrow band of monochromatic light at a specific wavelength. Laser light, in contrast, is composed of coherent light. It is purely monochromatic, directional, and has a single specific wavelength. Laser light is polarized, which means it can be concentrated onto a defined location or spot. Laser terminology. When dealing with laser technology, it is important to familiarize ourselves with certain terms. Photons. The photon is the basic unit of light and all other forms of electromagnetic radiation. It is considered both a wave and a particle. Wavelength. A wavelength is the distance between repeating units of a propagating wave. Every photon has a specific wavelength. The wavelength of a laser is measured in nanometers. The Lapex 2000 BCS has a wavelength range of between 630 and 680 nanometers. The electromagnetic, or EM spectrum, is the range of all possible electromagnetic radiation frequencies. EM radiation, with a wavelength between approximately 400 nanometers and 700 nanometers, is detected by the human eye and perceived as visible light. Photons with a reddish color have longer wavelengths than photons with a violet color. The shorter the wavelength of a photon, the more energy it carries. Joules. A joule is a unit of energy measuring heat, electricity, and mechanical work. It was named after English physicist James Prescott Joule. Many lasers use joules to describe the total energy their light delivers. 1 joule is equal to 1 watt for 1 second. Waveforms. The word waveform refers to the shape and form of a wave. The waveforms of photons emitted by different sources of light are varied. Superpulse. Superpulsing is a technique used that allows a laser to penetrate deeper into the body than a laser of the same wavelength that is not superpulsed but has the same average output power. Traditionally, cold lasers deliver photonic energy that ranges in power from 5 milliwatts to 500 milliwatts. Diode lasers. Different types of lasers have been used for many medical applications and aesthetic treatments. Diode lasers have been used in many applications, such as hair removal, vascular procedures, and body contouring. Their wavelength is near infrared at 600 to 800 nanometers. Factors for energy absorption. Many variables can affect the absorption of laser energy into the body. The wavelength, power, and size of the laser used will depend on the target below the skin. Once the laser has penetrated the body, chromophores absorb the light. A chromophore is the part of a molecule responsible for its color and the absorption of electromagnetic radiation. Absorption spectrum of chromophores in the skin. Each laser wavelength has an optimal absorption peak or depth of penetration. By isolating specific wavelengths, lasers offer very selective treatments for aesthetic purposes. For laser hair removal, the melanin within the hair follicle is targeted. For pigmentation and vascular treatments, the hemoglobin. And for body contouring, the adipocytes. Different lasers within the aesthetic industry are designed to penetrate to various depths depending on the treatment goals. Resurfacing lasers target the epidermis, while a diode laser is designed to reach the deep dermis and subcutaneous layers. The biological effects of lasers. The way laser light reacts when striking tissue is dependent on the type of tissue, the wavelength or color of the laser, its intensity or the amount of energy delivered, and the pulse width or the time interval over which the energy is delivered. When laser light is scattered, longer waves experience more scattering than shorter waves. When laser light is absorbed, it is absorbed by the chromophores in molecules.